Hello, hi everyone, and welcome to another stream by OneClass. My name is Nehel, and we'll be going over a few physics questions today. These are anywhere from the high school to university level questions, and we'll likely be covering around 10 to 12 questions in this live stream today. Just a little bit about myself very quickly. So my name is Nehal. I'm a graduate from University of Waterloo. I went there to study mechanical engineering, and I graduated there in 2018. After completing my graduation, I worked in the plastics industry for about 2 years, and now I'm looking forward to starting my master's degree at the University of Toronto as of January. All right, so let's get to solving some physics questions now. Okay, so the question one for today is based on this graph. So we'll copy that over in a second. So what's the question asking for? We have an object moving along a straight line, and we are given the graph of the position. What is the instantaneous velocity of the object at t equal to 4 seconds? Okay, so question one, I'm just gonna copy over the graph. Okay. All right, so the first question asks us for the instantaneous velocity at t equal to 4 seconds. So we see that 4 seconds is somewhere here, and we need to find the velocity. Now, given the position time graph, first of all, we need to recall what the formula for velocity is. So the velocity is the change in position with respect to time. So for part A, what we need to do is we need to calculate delta x over delta t, which is equal to velocity. And velocity can also be looked at as the slope of this curve, which will be equal to the velocity. So for the section C to D, we need to calculate the velocity, and that's given by this formula. So therefore, velocity is equals to delta x. So delta x from C to D is the point D minus the point C. So the D coordinate is 40, the y coordinate, and similarly the coordinate y coordinate for C is 10. So this would be equal to 40 minus 10 over on the delta t axis or the time axis. The delta is from 5 to 2. So this will be equal to 5 minus 2, which makes it 30 over 3 or 10 meters per second. Again, I really want to stress that always write the units in all of these questions. They're really important. Okay, let's look at part number B. The part B asks for in which segment of the graph does the object have the highest speed? So looking back at this graph, again, speed is change or total distance traveled for total time. So if we look at the section A to B, we travel only 10 meters in 1 second. For the B to C portion, we travel 0 meters in 1 second. For C to D, we travel a lot of distance, but it also takes us a lot of time. It takes us 3 seconds to travel these 30 meters. However, for the D and E phase, we are traveling all that distance in only 1 second. So therefore, just by looking at the graph, the speed is maximum for the DE portion. So this is, you have to use your graph interpretation skills to get this answer, but the correct answer for this is DE. So max speed is for segment DE. Oops. Okay. All right. And the final question is, at what time does the object reverse its direction of motion? So again, this is another question which we can straight away answer by looking at the graph. So reversal of position means that the object was going in one direction and now it has changed its direction. You were going in the positive direction, your position was always increasing, but then suddenly it decreased at one portion. So by looking at the graph, for A to B position was increasing, for B to C position was constant, so there was no change. For C to D it was increasing again, but for D to E the position decreased. So at what time? The time would be denoted by the point D, so which is at 5 seconds. So therefore at time equals to 5 seconds, or at point D, we reversed our position. So at t equals 5 seconds, we reversed our direction. Okay, that's it for this question. Let's just go through the solution here and make sure that everything's right. So for the first part, the velocity is given by the slope, and we can get that by delta x over delta t, which is correct, 10 meters per second. And then for the second part, which segment? So the segment is for the DE segment, that's correct as well. And then the position is increasing till 5 seconds. So that's correct. So the solution is correct. Okay, on to the next question. Question 2. Okay, this question says a car can decelerate at 5 meters per second square without skidding when coming to rest on a level road. What would be the magnitude of its deceleration if the road was inclined at 12 degrees uphill? Okay, so let's quickly graph this plot out. Um, okay, so for question number 2, we're given that now we want to decelerate at when we're going on an uphill. So let's say this is our uphill and this angle is 12 degrees, and let's say this is our car. Okay, now when it says it's decelerating, it means that its acceleration is actually in this direction. Looking at this diagram, we can say that we have a lot of forces acting on this car. So we can make the free body diagram of this. So let me just separate out the car here, and then draw the free body diagram. Okay, so the first force which is acting on this is the force of gravity, which is the weight of the car, which will be acting perpendicular to it in the downward direction. So this will be acting in the downward direction, and this will be equal to mg. Since it's on an incline, we can resolve this equation, or this downward force, into its x and y components. So those components would look like this. And then this angle would be equal to the theta angle, which is equal to 12 degrees. If we apply trigonometry, we can say that this force here would be equal to mg sine theta, and then this force would be mg cosine of theta. Okay. Other than these two forces, we also know that what would be the magnitude of its deceleration. Okay. So these are the two forces. So we can actually use that to calculate our final formula, and it's still decelerating at 5 meters per second square. So what we can say is our force is equals to, and the sum of the acceleration is ma plus mg sine of theta. So in this case, you can almost look at the mg sine theta as helping us decelerate because we were applying the brake and that was giving us the 5 meters per second. But on top of that, we got the mg sine theta to help us out here. So therefore, this becomes f, which will be equal to m times deceleration d. md is equals to a is given as 5 plus mg sine of theta. All the m's cancel out. Therefore, the deceleration when going up the slope is equals to a plus g sine theta, which is equal to a is given as 5 plus g sine theta. G is 9.8 and sine of 12 degrees. Let's calculate this value. 9.8 sine of 12 plus 5. So we get 7.03 meters per second square. So now since this is deceleration and it's happening in the downward direction, it'll have a negative as well. So just keep note of that. And that, which is why this deceleration was given as a negative quantity. So when we're accelerating, since the velocity is increasing with change in time, it's positive. Whereas when we're decelerating, the velocity is decreasing with time. Therefore, the final value, which is a vector value, is negative. Okay, so looking at the answer, deceleration of the car on a level road is no. So again, this is correct. The gravity also helps us decelerate the car, and the component of gravity is the overall deceleration is 7.03 meters per second square. So this answer is correct. Okay, next up, question 3. A particle of mass 6m is located 1.1 meters from a particle of mass small m. Where should we put a third mass m so that the net gravitational force on m due to the two masses is exactly 0? Okay, so this is a question for gravitational forces. We're given a mass or an object of mass 6m, and then we're also given another object of mass m. And now we want to place a third object of mass capital M such that the gravitational force on that mass is 0. So just intuitively, if we have a heavier object and a lighter object and we want to place a third object in between them, the third object will likely be closer to the lighter object because the gravitational force is directly proportional to the mass of the object. In this case, the 6m is heavier, therefore the third object will be placed closer. So this is just as an intuition. We can actually calculate the value to find out where exactly it will be placed. So let's say we put a third object or of mass capital M somewhere here, and we know by the distances rule this is 1.11 meters, and if we say that this distance here is x, this distance here would become 1.11 minus x. Okay, so for the system A, which is these two, the first two masses, we can say the gravitational force F1 would be equal to G m1 m2 over r square, which is the distance square. In this case, the distance is 1.11 minus x squared. And then F2, which is for the other two pair, which is for these two. So let me just label this F1, so F2 This would be equal to G M2. Actually, let's call this capital M and then M2. And let's call the other one G times capital M M1 over the distance square, which is just x squared in this case. So this equation becomes, since we know the masses, it becomes G times capital M. M2 is equal to 6m. So 6 small m over this distance square, 1.11 minus x squared. And then this equation here becomes, again, we know the masses, so this becomes 6 times capital M times small m over x squared. So now for the bigger mass, or for capital M to be in equilibrium, so for M to be in equilibrium, F1 will have to be equal to F2. So both the forces acting on the mass M will have to be equal. Therefore, we can say that Gm6m over 1.11 minus x squared is equals to Gm over small m over x squared. If you look at the two sides, a lot of the terms are common, so they will cancel out. So this would cancel out with the Gm here, the mass will cancel out with the mass here. Therefore, we'll be left with 6 over 1.11, oops, this is actually whole square, 6 over 1.11 minus x whole square is equals to 1 over x squared. If we take the square root of both the sides, that will be the quickest way of solving this equation. So taking the square root of both the sides, we're left with under root of 6 over 1.11 minus x is equals to 1 over x. Okay. And then if we cross multiply, we will get x under root 6 is equals to 1.11 minus x. And then if we take this to the other side, we solve for under root x. Under root 6 is actually 2.44. So 2.44x, and then once x goes to the other side, it becomes plus x equals to 1.11. And solving for x, we get 1.11 divided by this. So x we get to be 0.321 meters, and the other distance would be is 1.11 minus x is equals to 0.788 meters. So therefore, the object will have to be, so this distance here corresponds to 0.32, and then this distance here corresponds to 0.788 meters. So as per our intuition, the object is indeed closer to the smaller or the lighter object as opposed to the heavier object. Okay, so let's check. So they have taken the distance x to be the distance between these two masses, which is also correct. I do want to state that if instead of drawing it like this, if we drew this question out in a bit in a different manner, such as if we looked at it, let's say we didn't use the intuition that it has to be closer to the small m mass, and if we drew it like this, okay, we would still get the correct formula because our equation, our a quadratic equation would be modified to help out with this. So this would be 1.11, and then this would be x, and our formula would still be the same. Again, if we do another case where instead of it being on the right side, we put it over here, capital M. Again, this would again change the quadratic equation, but the final answer would be the same. We would get x to be a value which is negative, so it pushes it closer to the negative m or the smaller mass, and that would help us get the final answer. So this answer is correct in this case. Okay. All right. Let's go to question number 4. For question 4, part for part A, when solving the problem using the quadratic formula, what does the plus or minus stand for when completing the problem in a calculator? So any quadratic equation, such as ax squared plus bx plus c, can have two roots. That is based on the determinant, and we can sort of look at it such as determinant is given by b squared minus 4ac, and if this value is greater than 0, this has two real roots. If b squared minus 4ac is equal to 0, then it has one or distinct, I should say, two distinct real roots. It has one distinct real root, and then for the third case, it has no real roots. No real roots. So essentially, what we're trying to say is, if we have, if I draw um, the axis, and if I have a point 0, typically when a point -2, or sorry, a +2 is a root of my quadratic equation, the corresponding point -2 is also a root. So essentially, when we plug it into the calculator, we are trying to adjust for the negative part as well. So that is the reason why. And then this is how we calculate, and we're doing plus or minus on that value. So that's correct. Okay, let's go on to our next question. In loading a fish delivery truck, a person pushes a block of ice up a 20-degree incline at constant speed. The push is 150 newtons in magnitude and parallel to the incline. The block has a mass of 35 kgs. Is the incline frictionless? If not, what is the force of kinetic friction on the block of ice? Okay, we have another incline question here. So for question 5, we have an incline and a box is being pushed, a block of ice is being pushed on this incline, which is 20 degrees steep, and this is being pushed with a force of 150 newton, which is parallel. So this force here is 150 newtons. And now the question, the first part asks us, is the incline frictionless? So for part A, let's go ahead and draw the free body diagram of this block of ice. So it would look something like this. We have a force of 150 newtons. We have the weight of the box acting downwards, mg. We can resolve this into two components, this and this, where this angle is 12 degrees. This component will become mg cos of 12 degrees, and then the parallel component will become mg sine of 12 degrees, and then we also have a normal force as a reaction force from the incline acting on the box. Okay, so now if I were to go ahead and write the equations for motion along the parallel to the incline, what I would get is I would get F minus mg sine of 12 degrees is equals to ma. Okay. Uh, so now for the incline to be frictionless, we know that these two values must be the same. F and mg sine 12, therefore they would cancel out and then there would be no acceleration. So let's compute those values. We know F is already equals to 150 newtons, but mg sine of 12 degrees is equals to 35 times 9.8 times sine of 12 degrees, and this value is equal to 35 times 9 times sine of 12, 65.49. So this value is equal to 65.5 newtons, let's say, and clearly these two values are not equal. Therefore, we must have an additional friction component acting on this block in order for this to move up the incline without any acceleration. So for part B, we actually asked to calculate the force of kinetic friction. So that would just be the difference of these two forces. So small f, which is the kinetic force, is equal to 150 minus 65.5, and that is equal to 84.5 newtons. Okay, that would be the friction force which is acting on it. So let's make sure that this answer is correct. Oh, was the angle 20 degrees? My bad. The angle is actually 20 degrees. So this value here is 20 degrees. So this value is likely going to change. Let me just compute that. So 35 times 9.8 times sine of 20 degrees, it's 117. So that was correct on the right hand side. This is equal to 117.3 newtons, which again we can say that those two are not the same, so therefore the incline is not frictionless, and to calculate the friction we can subtract the two values. I was a bit skeptical because usually friction is not equal to such a big value, so this looks better. 150 minus 117.3, 150 minus answer is 32.6. Okay, so this answer is correct. That's perfect. Okay, so the solution is correct. Let's, before we head over to the next question, give me 1 second. Alright, I'm back. Let's get on with the next question. Question number 6. One end of a cord is fixed and a small mass is attached to the other end, where it swings in a section of vertical circle where theta is given as shown. What is the tension in the string? Okay. So for this question, let's first draw the free body diagram of this block. So we have this. This is, oops, let me just use actual straight lines. Okay, and then we have okay, let me just draw that. So the pendulum is actually at an incline and it's over here, and this angle is theta, and this is moving with a velocity of v. So now if we were to look at the free body diagram of this, we would have a few components acting on this. So if I draw the free body diagram, we would have the tension acting along the string. We would also have the weight of the object, which is acting downwards, which would be mg. If I were to stretch this line down, this angle would be equal to theta as well. And if I resolve this mg into two components, I would get this component would be equal to mg of cos theta, mg cos of theta, and then the component in this direction would be equal to mg sine of theta. Okay, so the question is asking what is the tension in the string. So if I were to calculate or sum all the forces along the string, what I would get is I would get T minus mg of cosine of theta is equal to ma. Now A is actually the centripetal or the radial acceleration, which we will call AR. We know for a pendulum in motion, AR is actually equal to V square over R, where V is the velocity and R is the radius, or in this case, the length. So we're given V to be 7.4 and R is 3. So this is equal to 7.4 squared over 3, which is equal to 7.4 squared divided by 3, 18.2. 18.2. Okay, so now if we plug this into the equation above, we would get T is equal to, we're solving for T, MAR, AR we just calculated to be 18.2 and mass is 0.6. So we get 0.61 times 18.2 plus mg, m is again 0.61 times g is 9.8 multiplied by cosine of theta, and theta is 29 degrees, cosine of 29 degrees. So when we solve this, we get 0.61 times 18.2, which gives us 11.1 plus 0.61 times 9.8 times cos of 29, which gives us 5.22. Therefore, this value becomes plus 11.1, 16.32. Okay, so that's the tension. What is the radial and tangential component of the acceleration? So for part 2, for part B, we need to calculate V t and we need to calculate VR. We just already calculated VR, or we are given VR in fact, which is equal to 7.4 meters per second. But to calculate Vt, we can use again the free body diagram which we drew, and the tangential component of acting on this would be equal to, if I go back up, mg sine theta is acting in the tangential direction. Therefore, that would be equal to the acceleration. So again, if I were to quickly draw the free body diagram and only list out the forces in the tangential direction, we only have mg sine of theta. Therefore, mg sine of theta is equal to ma. The m get cancelled, and a actually is at. At is equals to g of sine theta, which becomes g of sine 29, so times sine of 29 degrees, which we get to be 4.75. Okay, over here, let me just fix this, which is why I was a bit confused why we actually need to find acceleration tangential and acceleration radial. So AT we got to be 4.75, and radial acceleration is nothing but v squared over r, which we calculated above to be 18.2. Okay, so this part is done. For the next part, it's asking what's the total acceleration. So for part C, we need to get the total acceleration. If you remember, the rules for vector is that if you have two vector components, in our case AT and AR, the third component A can just be given by the Pythagoras rule. So A would be equal to square root of AT square plus AR square. Okay, so if we calculate for this, we get 4.75 squared plus 18.2 squared, and the under root of that value, so 18.8 meters per second. Meters per second square. Okay, so that should be the answer in this case. So this was correct. They calculated that. The tension they got to be m equals to AR, which is incorrect because they did not take into account mg component, so mg cos theta component. So this is incorrect. The tangential acceleration is 4.75, so that is correct. And then the final answer is also correct. But the first part, the part where we calculate the tension, is incorrect. So the tension in the string should be 16.32 newtons. In the free body diagram, there is mg cos theta acting in the downward direction, making the equation to be and P minus mg cos theta equals to ma, where we solve for t and a is the radial acceleration. AC. Okay, so the solution unfortunately is incorrect. Okay, next up, question number 7. Batteries are rated in terms of ampere hours. For example, a battery that can produce this much current is rated at this many ampere hours, so that's okay. What is the total energy in kilowatt hours stored in our 12-volt rated battery at this many kilowatt hours or this many ampere hours? Okay. So for this question, we're given a battery which has V equals to 12 volts, and it's rated at ampere per hour is equals to 55 ampere hours. So this question is fairly straightforward. If you recall the formula for power for in electrical terms is equals to uh, IV. In this case, we are given V to be 12 and I is given in terms of ampere hours, which is 55. This would give us a value which is in watt hours. So that value would be 12 times 55, which is 660 watt hours. And then if we need to convert it to kilowatt hours, we will divide it by 1000. So 66 watt hours is the power, and then that divided by 660, sorry. So that's divided by 1000 gives us 0.66 watt hours. Kilowatt hours. So that's the answer for the first part. And for the second part, we have a charge of 6 cents per kilowatt hours. What is the value of electricity produced by this battery? Okay. So if we multiply the two, we're given a quantity of $0.06 per kilowatt hours. So if we multiply by the total power, we can get the total cost. So we get 0.66 times 0.06, which is equal to 0.0396. Now, since this is in kilowatts, actually those two cancel out, so this answer is correct. 0.0396. Okay, so fairly easy question. You just need to remember the formula for the power, and then also you need to know to convert from one unit to the other. You would look at the units and try and identify if you multiply them or divide them in order to get the final answer, which is in dollars. So in this case, you multiplied them. Okay, so looking at the solution, so kilowatt hours is 0.66 and the value is 0.0396. So this answer is correct. Alright, jumping over to the next question, question number 8 for today. Two vectors have magnitudes of 10 meters and 15 meters. The angle between them when they are drawn with their tails at the same point is 65. What is the component of the longer vector along the line of the shorter? Okay. So we're given two vectors such that their tails coincide. So it's a situation like this. And we're given that the magnitude of the two are 15. So the longer one is 15 and the shorter one is 10 meters. Okay, we also know that the angle between the two is 65 degrees, and we're asked to find the component of the longer one along the shorter one. So if we look at just the longer one, we can resolve this into two components such that it has two components. One is in the y direction and then one is in the x direction. Now, since this angle is given, this component would be the cos component and this is the sine component. So just a way to remember that is P over H is sine and B over H is cosine. So in this case, the base is cosine. So this would be magnitude, which is 15 times cos of theta. And then this would be 15 times sine of theta. Okay. So looking at this, we can say that the component of the longer vector along the line of the shorter vector would be 15 cos of theta, where theta is 65 degrees. So we can compute that. 15 cos of 65 degrees is 6.33. Okay, so that is the bigger vector along the shorter vector. Okay. And I did forget the units, so that would be meters. And that's exactly what's in the solution as well. So the solution in this case is correct. Okay, off to the next question. Oops, question number 9. 3 blocks A, B, and C, each having a mass capital M, are connected by strings as shown. Block C is pulled by a force F that causes the entire system to accelerate. So we're neglecting friction here and we're finding what the net force acting on block B is. Alright, so we're given a scenario where we have the 3 blocks. Let me just copy this over. Okay, so if I'm going to need a few free body diagrams in order to solve this question. The first one I'm going to do is of the system as a whole. So if I look at the system as a whole, what I actually have is a mass of 3m being pulled by a force of F. Okay, so what I can say is for the system, the equation of motion is F is equals to ma. In this case, m is equal to 3m, 3 capital M, a. We don't know the acceleration, but we get an equation for the overall system. Okay, so I'm gonna just say for entire system, we get this. Now for just block A, what would be our equation of motion? If we look at block A, we only have the tension force pulling it. So we have a tension force T pulling this block A, and this is accelerating with the system with the same acceleration. So in this case, we can say T is equals to ma. Okay, let's call this TA just for clarity. All right, and if we look at block B, we have TB pulling it and then TA wanting to bring it back. So in this case, the equation becomes TB minus TA is equals to again MA. We know already that TA is equals to MA as well. Therefore, we can say TB is equals to MA. Okay. So the net force acting on B is essentially, now that we know what TP is, um, therefore net force on block B would be, again, let me just draw this, TB, which is the tension, and TA. So net force is TB minus TA, which is equal to, so some force F, FB is equals to TB minus TA. FB is equals to TB is 2A and TA is MA. 2MA minus MA. Therefore, we get the force to be equal to, this force becomes equal to MA. Now, we can't leave the answer in this form because we actually were not given what A is. So we need to find out, express this in terms of what we were given. So we were given this expression, right? So from here, we can say that MA is actually F over 3. So using that, we can say that FB is nothing but the overall force divided by 3. Okay, so that's the final answer. Okay, let's compute, assuming that the net system moves with a constant acceleration, is equal to net force acting on B. So the answer is correct now, but I feel that the explanation could have been better. So I'm just going to mark this as incorrect. While the solution is correct, the explanation can use a few free body diagrams to help the understand how different forces are acting on different blocks. Okay, so I'm going to mark it as incorrect for now. Okay, next up we have another inclined question. This is question 10 for today's stream. We have a log of 216 kgs, which is pulled up a ramp by the means of a rope, which is parallel to the ramp. The ramp is inclined 32.5 degrees with respect to the horizontal, and the coefficient of kinetic friction is given. The log has an acceleration of this much. We'll find the tension in the rope. Okay, so if I were to draw the free body diagram of this box, which is at an angle which we are given to be 32.5, I would have a component mg acting downwards, a component mg cos of theta, another component mg sine of theta. Since this is not frictionless and friction always opposes motion and this is being moved to the right, we would have a frictional force F acting opposite to it as well. And then finally we have our normal force, and this is all being pulled by a tension force T. So sum of forces along the vertical direction, if I was to do that, I would get N is equals to mg of cos theta. Theta is given to be 32.5 degrees. And then in the x direction, if I were to do the sum of forces, I would get T is equals to mg sine of theta acceleration. Okay, we are given the acceleration. So in that case, we would have ma is equals to t, which is in one direction, and then it's being opposed by the frictional force and mg sine theta. Okay, so if we were to solve for t, we would get t is equal to ma minus f minus, sorry, plus mg sine of theta. F, which is the frictional force, is nothing but the frictional component times coefficient times n, which is the normal force, and we know n is equal to mg cos theta. So for t we get ma plus mu times mg cosine of theta plus mg sine of theta. And then computing these values, and I'm going to plug in the values and then calculate it. Mass is given to be 216 times acceleration is 0.698 plus coefficient is 0.75 times mass again is 216 times g, which is 9.8, and then cosine of 32.5 degrees, 32.5, plus mg, m is 216 times 9.8 times sine of 32.5 degrees. Okay, not very satisfied with how this turned out, so you know what, I'm gonna quickly as I said, t is equals to ma, m is 216 times 0.698 plus, actually I'm going to take mg common here, so mg common here becomes 216 times 9.8 times mu times cos theta, which is 0.758 times cosine of theta, which is cos of 32.5 plus sine theta, which is sine of 32.5. Okay, this is much better. And if we were to calculate this value, we would get the final retention. 216 times 0.698, which is 150, so that's the first term. 150.76 plus 216 times 9.8 gives us 2116.8. 2116.8, and then the value inside gives us 0.758 times cos of 32.5 plus sine of 32.5 gives us 1.17. 1.17, and then this final answer is equals to 2641. Okay, perfect. So they also got the same answer. So this answer is equals to 2641 Newton. Perfect, this answer is correct. And they've applied the same free body diagram and equations of motions. Alright, I think that's everything for today, guys. Thanks so much for tuning in. I hope you gained something of value from this tutorial or from this stream. If you do like the stream, please feel free to check out our website. The link is in the description, and please feel free to like, comment, and subscribe to the channel. Thank you so much, and this is Nehel signing off.